everyone. Module 5. The next topic is graph-based clustering. This graph-based clustering algorithm, it uses a number of key properties and characteristics of graphs. So the following some of the key approaches used by the particular algorithm. So first one, specify the proximity of graph to keep only the connections of an object. Okay, so respect to this graph theory, it can provide more detailed information about the inner structure of the data set in terms of clicks. And it defines the similarity measures between two objects based on the number of nearest neighbors that they share. Okay, so that is what the subset of nodes where each pair of element is connected. So cluster is nothing but highly connected groups of nodes, and centrality is important nodes and hubs. So outliers are unimportant nodes. So based on these only the performance, the activities that we are going to perform over here. So define the similarity measures between two objects. It based on the number of nearest neighbors that they share. So even core objects and build clusters around them. So now like again the core and whatever the previous concepts that we discussed, that will come to the picture over here. So and with respect to this, use the information in the proximity graph to provide more sophisticated evaluation of whether two clusters should be merged or not. So here the classification classified into following. One is MST, another one is opossum and chameleon and Jarby and SSN densities. So each and every one like will discuss what it will do, how it is going to play a role. So the ideal process of clustering using specification. So the specification is a proximity graph. It should be regarded the initial step before the use of the actual clustering algorithm. These are like give graph-based clustering algorithm. And first one, like what we have, MST. MST is a minimum spanning tree. MST is minimum spanning tree. So this minimum spanning tree with respect to the graph is a subgroup that has a cycles, no cycles, and contain all the nodes of the graph, and it has the minimum total edge weight of all possible spanning tree. So this MST can be viewed as a clustering algorithm based on the specification of the particular graph. And here this MST clustering algorithm like it will compare with the minimum spanning tree for dissimilarity graph. So that is the first step, and next one is it will repeat the step, and it will create a new cluster by breaking the link corresponding to the largest dissimilarity. So until only the singleton cluster remains. And next classification we have opossum. So this opossum is nothing but O for optical partitioning of spare similarity using METIS. So this opossum is a clustering technique that was specifically designed for clustering spare with high dimensional data such as document or market basket data list MST. So it performs clustering based on specification of a proximity graph. And this opossum clustering algorithm, first it will compare sparified similarity graph and partition the similarity graph into k distinct comparisons using METIS. The strength and weakness is it is simple and fast. So it's a it will partition the data into equally sized cluster with roughly equally sized cluster with depend on the goal of clustering, which can be viewed as advantage or disadvantage because they are constrained to be roughly equal sized. And third one is a chameleon. So this chameleon is nothing but a hierarchical clustering with dynamic marketing. So like previously we discussed algorithmic clustering algorithm. So it contains the initial partition of the data using a effective graph. So initial partition of data that we are using over here for the effective um, utilization of the data or the partition of the algorithm. So this algorithm works in two phases. In first phase, use a graph partition algorithm to cluster objects into a large number of relatively small clusters, set of clusters. In the second phase is use a algorithmic hierarchical clustering algorithm to find a genuine cluster of repeating combining subclusters. Okay, so based on that it is going to perform the and this chameleon algorithm will perform in such a case, and the strength and limitations are can effectively cluster spatial data even though noise and outliers are present in the clusters are of different shape, size and density. And it has a problem when the partition process does not produce sub clusters. So as it is often the case of high dimensional data. And next one is a Jarvie-Patrick clustering. So here the threshold will be fixing some threshold. The algorithm initially replaces the proximity between the 2 points with the SNN similarity. The threshold is that used to sparify the matrix of SSN similarities. And initially the clusters are simply connected components of SNN graph. And it compared the SNN similarity graph. The first step it will perform the task, and the second one it sparify SNN similarity graph by applying a similarity threshold, and finally find the connected components with respect to the clusters, the specified SNN similarity graph. So it will be according to these activities it will perform. The strength and limitation of this is it based on the notation of SNN similarity, and it is good at dealing with the outliers and can handle clusters of different size, shape and densities. So Jarvie-Patrick, that will call it short form, call it as a JP. So this JP clustering works well for high dimensional data but somewhat brittle. That is, it may split two clusters or join clusters that should be kept separate. And potential limitation is that not all objects are clustered. And last one is SNN density cluster. This algorithm is similar while clustering algorithm in that which stands SNN situation graph. Initiated of using it is initiated where the threshold to specify SNN similarity graph, and this SNN density based clustering algorithm it applies dB scan. So initially this algorithm it will work while compare the SNN similarity graph and apply dB scan with the specified parameters. So this algorithm automatically determine the number of clusters in the data. So note that all the data points are clustered. So strength of this is the limitation of the density based clustering or similar to that of the JP clustering, and the use of the core points and SNN density or consider which is flexible to SNN density based clustering. And here it is a collection of a wide range of very popular and clustering algorithms which are based on graph theory and organize information in large data set to facilitate users for faster access to required information. So the idea behind is the objects are represented as nodes in a complete or connected graph, and assign a weight to each branch between the two nodes x and y. The weight is defined by the distance between the nodes. So the clustering distance between cluster distance between the objects. And the minimal spanning tree, a minimal spanning tree of a connected graph is vertices and edges. So which is connected subgraph with a minimal weight that contain all nodes of G and has no cycles. So next topic will be discussing the clustering evaluation.